Welcome back to our YouTube channel. Today we are going to look at a statistical test called a T-test, or a student T-test. And we are going to see how it is being used in Excel and STATA. There are three types of T-tests, which is one sample, an independent sample, and paired sample. So don't worry about these words, we are going to look at what it means. So we begin with what is a T-test? This is a test that is used on means between two groups or one group of individuals in testing a hypothesis. So a T-test tells you how significant the differences between groups are. In other words, it lets you know if these differences or the measured means could have happened by chance. So, like I told you before, that the reason why we do research is to prove beyond chance that what we are observing, what we are observing did not happen by chance. So, for example, someone might observe that every student that comes in when he's 25 years old, their weight is around 75 kilograms. So that might have happened by chance, or it is true that everyone that is 25 years old has a weight of 75 kilograms. So if we want to prove that it's not by chance, we go and collect data, then we do a hypothesis test to see if this happened by chance or it is true. And by that we shall get what we call a p-value. A p-value is the probability that tells us that if this happened by chance or not. I think we saw it in Introduction to Data Analysis. You can check out our previous videos. So what are the types of t-test? We have one sample t-test. This one is tests a mean of one group against a known mean. So data is collected on one group of individuals and compared to a hypothesized mean. So, for example, if we would like to test the hypothesis that the mean weight of boys at 25 years old is 75 kilograms. So someone, like a hypothesis is, like I said, hypothesis is a claim about a group of people or a population. Someone might claim that all boys at 25 years of age have a weight of 75 kilograms. So this can have happened by chance, or it is true. If you want to test if it happened by chance or if it is true, then you do what we call a hypothesis test. And this hypothesis test, we shall use a one sample t-test as the test statistic, and we are looking for significance. If it is significant, so we say this one is significantly different from 75 kilograms. That means this could have happened by chance. If it is not significant, then we fail to reject the null hypothesis and we say the means the mean weight of boys at 25 years is equal to 75 kilograms. So we have the independent sample t-test. So an independent sample t-test compares two means of two independent groups. Like you hear the word independent, data is collected on two separate groups of individuals. So these people are separate, or these groups are separate. So we could have a hypothesis that says weight gain from eating chocolate is the same as the weight gain from eating rice. So our null hypothesis would be there is no difference in mean weight gain for people who eat chocolate and people who eat rice. So what we do, we will feed the two separate groups of people, with one with chocolate and another one with rice.
So after some time, we take their weight and we see if their weight is significantly different. So we do what we call the independent samples t-test. Or someone might say the weight of all 25-year-old males and females is the same. Ideally, the weight of female is different from male. Ideally, it should be. But someone might make a claim that there is no difference because you don't have any basis to say that they are different. You can't just eyeball and say the weights are different. So if you want to test this hypothesis that indeed the weights are different, so we go, for example, in a school, and we get all 25-year-olds, the male and the female, and we collect all their weights. So we do what? We use an independent sample t-test to see if their mean or the average weight of all these groups between the men and the male and the female is statistically significant, or statistically different from each other. If it is not different, then we say it's not. There's no difference. If the difference is there and it's not statistically significant, then we conclude that it is the same. Please note here that by getting the average mean of weight between boys and girls, the averages might not be exactly the same, but they could be different. But we want to see if that difference is statistically significant. So we say they are significantly different from each other. So let's look at another t-test, which is called a paired sample t-test. So a paired sample t-test, or the dependent, as you hear it, it is paired, or it depends on each other. It's a dependent t-test. So a paired t-test compares means of the same group at different time intervals. So you collect data on the same group of individuals at 2 time points. For example, if someone says there is no difference in mean mark you score when you repeat a class, so we say that repeating a class does not change the mean mark score of students. For example, in a test. So what we do, we get all those students that repeated the test or a course unit, and we get their marks before and their marks after. Then we get the mean mark and we see if this average is the same as mean. If this mean mark is statistically significant, different from each other. If they are statistically different from each other, we want to see if that difference is statistically significant. And significance is tested by a p-value. So you see that the reason why it is called a paired or dependent, because the first mark student scores, the second mark student scores, is dependent on the first mark he will score. Because if he scores 30, he goes back and reads because it is a repeat. So you see that the second mark is dependent on what this person scored in the first mark. If he got a 90 in the first mark, maybe this person will lose and doesn't read for the second test. So the second mark will be dependent on the first mark this person scored. But the whole issue why it is called dependent, because we are measuring the same outcome on the same person. This person does this test at point A, then does the same test at point B. So what are the formulas? What do we need to calculate the t-test? We need the means of the sample. We need the variance of the sample, and we need the number of individuals in the sample. For a one sample t-test, this is the formula. It is quite simple. X bar, that is the t-test, minus the mean. X bar is the mean of the sample, minus the mean, which is the mean of the population, over the standard deviation of the sample. But the standard deviation of the sample is equal to, the standard error. It's not the standard deviation. The standard error of the sample is equal to standard deviation over square root of n. So you see why we need the test value there, the hypothesized mean. So in the independent t-test, we have two groups, for example, boys and girls. X bar 1 is the mean from one group, X bar 2 is the mean from another group, N1 is the number of individuals in one group, N2 is the number of individuals in the second group, and S is the pooled standard error. So the pooled standard error also has a formula. So this is the formula for independent. If you want to calculate them manually, for example, if you are given a test, or if it is a theoretical exam, this is the formula you will use. So for paired t-test, we use a D instead of a mean. So D bar is the mean difference because we said the second mark is dependent on the first mark. So we subtract the second mark from the first mark, and we get the mean of that difference over the SD over square root of n over the standard error, standard deviation of the deviations. So we call those differences deviations, or differences anyway, over square root of n, which n is the number of pairs. So which is still the number of the population in the sample. So that's how we do a t-test. Now let's go ahead and look at how we could calculate this in Excel and STATA. So this is our Excel file I prepared for one sample t-test. We have a student number as the ID and their weight gain. Let's say our hypothesized value is 75. We want to see if it is statistically, the mean is statistically significant from 75. This is for the independent, the weight of boys versus the weight of girls. And this is the paired, the mark 1 versus mark 2. We want to see if these means are statistically different from each other. So, but by first we can get the averages. We want to demonstrate something. So the average of this we shall say equals average or mean. Actually it has average. No. Equals average of B2. This is 62 point, and the average of this, you just shift to this side. This is 71.1. You see that this the mean mark of let's say of the repeat is bigger than the first one, but we want to see if this difference is statistically significant. So they could be different, but in statistics they are almost the same. They don't make any difference.
So we want to prove beyond that doubt. So let's remove this. So if you want to do a t-test in Excel, you go to data, data analysis, then look for, we want a paired t-test. So the range of cells, we only include the marks. Then for the we don't have a hypothesized mean. Maybe we could say if it is significantly different from maybe 80%, that would be the hypothesized mean. So I'm going to put the output on the same. Let's say okay. So this is the test, the t-test for paired sample. So we got the mean for group 1 as 62.8 and 77.1. The variance here is 268 and here 170. Observations are all 30. Let's see. Pearson correlation, the correlation between these two samples is 0.13, which is very low. There is no mean, hypothesized mean. The difference between 77 and 62 point something, 62.833 is 29. So the test statistic, or the t-test, is negative 4.0. Then we have this is the one tail. We shall look at this in hypothesis testing, but these are p-values. One tail and two tails. One tail means both sides of one side of. If we had said that this mark goes in the positive, well, the mark increases, then that's one tail. If it is two tail, it means this mark of before and after could go both ways. It could be lower or higher. So both, this is the p-value for one tail and p-value for, they are both less than 0.05, which is statistically significant. So we conclude by saying that the mean mark of a repeat test is statistically different from that of the first test. So if it is different, and we see that the 77.71 was the mean here, we conclude by saying that students pass, all score more marks in a repeat test. So we can remove this since we are going to use this in STATA. So we can now go to independent t-test. Still we'll go to data analysis, data analysis. I think Excel doesn't have one sample. It has only two samples. So if this is a tool for assuming equal variance or unequal, let's assume equal variances, though the test won't change that much. So we put the first column, then we put the weights of the girls. We have no hypothesized mean, so we shall put our results here. So now for this sample, we see that the weight of boys, which is variable 1, is 62.833, and that of girls is 55.166. The difference is 58. Okay. This is not difference. DF means degrees of freedom. Sorry, it's not difference, it's degrees of freedom. Degrees of freedom, it means we get the total n, which is 60 for this example. These are 30 boys and 30 girls. So minus 2 because there are two groups. So degrees of freedom equals n minus 2 since there are two groups. N is the total number of the observations, which are 30, 30 in, which are 60, 30, 30 in each group, minus the number of samples, which are 2. So a t-test works with the degrees of freedom. And if we shall look at the degrees of freedom more in hypothesis testing. So the test statistic of this at different or at 58 degrees of freedom, one tail is 0.02. Still, this is less than 0.05. So we say if it was one tail, if our hypothesis was the mean weight of girls could be either lower or more than for boys, then this would be statistically significant. For two-tail, we could say that it could go both ways. One tail, it goes one direction. It is either lower or it is higher. A two-tail means it can be either lower or higher. I don't know if you get the difference here. So for a two-tail, this is not significant. It is 0.05, mean it is not less than 0.05. So for this case, we shall go with a two-tail t-test because we don't know. The mean weight of girls could be either lower or higher than for boys. So we say there is no difference in the mean weight of boys and girls. So you see how statistics is interesting. These two values by eyeballing, they are different. But the test statistic is telling us they are not significantly different from each other. So that is doing a t-test in Excel. Let's do it in STATA. So this is Stata. We shall first import this Excel. Shall first look at the data. Yes, we are going to start with one sample. We shall import these as we shall import the first row as variable name. We have students number and weight. When we browse, we can look at it, student number and weight. So we want to do one sample t-test to see if the mean weight of students at 25 years is 75, or it is statistically different from 75 kilograms. So we go to statistics, summary tables and tests. We go to classical test for hypothesis and we choose a t-test, mean comparison test, or t-test. Let's see, calculator. We have a one sample size. Oh, this is a calculator now. So let's go back. We have a one sample. The variable name is weight.
The confidence level, we shall use 95%. The hypothesized mean is 75. So let's press OK. So this is the output. We want to tell, we did a t-test on weight and the hypothesized mean is 75. There are 30 observations of students. The mean was 61.8667. Standard error is 3.1. Standard deviation is 16.9. And this is the confidence interval of the mean. So these are the hypotheses that we have here. The first one says the null hypothesis is mean is less than 75, which is statistically significant. Another hypothesis test says the mean is not equal to 75, which is still true. And the third hypothesis says mean is greater than 75, which is not statistically significant. So if our hypothesis was there is no difference, but looking at this and this, there is a difference, and that difference is statistically significant. So this 61.8667 is statistically different from 75 for this number of observations or for this sample of students. So if we say the mean is less than 75, the 61.8 is statistically less than 75. This is true. 61.8 is not the same as, is not equal to 75. This is also statistically significant. So we reject the null hypothesis and we say the mean age of boys at 25 years of age is statistically different from 75 kilograms. So now let's look at another. Let's clear this and we look at another. Oh, okay. Let's clear this and we look at another test, which is the independent. So we import the same Ttest. So now we're going to import sheet 2. And we import the first row as variable names. So when you browse, you will see that so you have the student IDs, weight for boys and weight for girls. So I want to see if these weights are statistically different from each other. We still go to statistics, classical hypothesis tests, then we go to t-test. So we are having two groups, two sample using groups. Yes, we are using two groups. So the variable name in one group is boys and another one is girls. Unequal variance, we don't know. Let's leave it empty. So let's say okay. More than two groups found. Only two allowed. What did I say? Oh, sorry. So let's see where the mistake was. Statistics, hypothesis. Oh yeah, we said one sample mean comparison by. Okay. So this would have worked if we had a variable, maybe gender or sex, and that sex had boys and girls, or male and female, and the variable for
for weight, I can do it and we see. We can, okay, I'll do it last. So this is what we are going to use. This is going to be variable 1, weight for boys, variable 2, weight for girls. And this is our t-test. So we see that we have weight for boys, observations are all 30. The mean for boys is 62, mean for girls is 55. This is the standard error, this is the standard deviations of the mean and the 95% confidence interval of the mean. So the difference, the mean difference, the combined mean is 59, combined standard deviation is this, and the difference is 7.66. The standard error of the difference is this. So we want to see if these hypotheses are true. One says that the difference is less than 0, meaning if you subtract the weight of both, if the weights are indeed equal, if you subtract them, they should be 0. So the difference is less than 0. A t-test, the p-value is not. The probability that a t is less than a small t, 0.9. This is a p-value. A null hypothesis that says the difference is not equal to 0 is also non-statistically significant because 0.057 is not less than 0.05. The null hypothesis that says the difference is greater than 0 is statistically significant. So if our null hypothesis was like the weight of boys is greater than the weight of girls, or is more than the weight of girls, then this hypothesis would be true. Also, if we had a hypothesis that says the weight is the same, this test would be also true because the difference is greater than 0, is statistically is greater than 0 and it is statistically significant. So we conclude that the weight of boys is not the same as the weight of girls. So let's look at the last, and that is the paired t-test. So let's clear this. We import no, we are importing for a paired. So by browsing, we can see that we have one mark and we have mark 2. So we want to see if the first test, the mean marker in first test is statistically different from mean mark in the repeat test. So we go and use a paired t-test, statistics, classical tests, t-test, and we say paired. The first variable is mark 1, second variable is mark 2. So these are the means, observation, mean, standard deviation. This is the difference of the mean. This is standard error, standard deviation. So there is a difference, and the difference is negative 14%. If their percentages could be 14%. This is the difference in the marks. So we say that the students, if they repeat the test, their mark increases by 14% on average. This is what it means. So is this difference, the negative 14.2, is it statistically different from 0? So we say that if the mean difference is less than 0, this is true. Mean difference is not equal to 0, this is true. Mean difference greater than 0, this is not true. I'm saying not true because the p-values. The p-value here is not less than 0.05 because we use the 95% confidence interval. So the difference is not equal to 0. I'm saying it is true because the p-value is statistically significant. It's less than 0.05. Also less than 0 is statistically significant, which is less than 0.05. So we conclude that there is a difference between the marks scored by students in a repeat test from the first test. So that's all we had for the three statistical tests, which is the independent t-test, the paired t-test, and the one sample t-test. We shall look at hypothesis testing in the coming videos. We shall also look at linear regression, multiple linear regression, logistics, survival analysis, and so many. So don't go away from our channel. Keep subscribing and put the notification bell and give likes to our videos. Thank you.